We are here to start up with a new chapter, that is column and strut. In the column and strut, we are in daily life, we are using column and strut in our life. We are having millions of examples of column and strut in our daily life. Let us see that how we need to calculate that what amount of load we need to apply to onto a column. What amount of load has to be applied onto a strut so that we get a safe design. See, first of all, what is a column? What is a strut? Basically, a vertical member which is having a compressive load which is perpendicular to horizontal is defined as a column. Say, this is a column. Why this is a column? It is perpendicular to horizontal and a compressive load has to be applied from the above the lintel. So, a member or a member if a strut is vertical inclined 90 degree to horizontal, then it is defined as a column. First thing. Second is, what is a strut? Strut is basically, it is a member which is not perpendicular to horizontal. If a column has been deviated to some angle, say 5 degree, 10 degree, then it becomes a strut. So, a member or a structure of a bar which carries an axial load, a compressive load, load has to be applied on the upper end, then it is a strut. How it becomes a strut? That it is not perpendicular to horizontal. It has some angle. So, when a member or a structure of a bar which carries an axial compressive load, but it's not vertical, it is at some angle, so it is called a strut. So, you came to know the difference between a column and a strut. The similarity is that they both are having compressive load. The dissimilarity is that one is totally vertical and other is at some angle. So we do not define this as a strut. So let us move further. A member in the position other than vertical is called a strut. It may be pin joint, it may be a hinged joint, it may be a fixed rigid joint from one end or from both ends. We will see that conditions also, that how they are varying. If both ends, say, now come to the examples of the struts. Your connecting rods, they are not exactly vertical. That is, they are at some angle, but they are experiencing the compressive load. So we call them as a strut. Your piston rod is exactly not perpendicular, but exerting some compressive load will come under the strut. Your links used in the forging machines are also strut. So how do they get failure? The failure in the struts or in the columns is due to three types. First will be purely compression, because compressive load is acting onto the member of the strut or a column. Second thing is that buckling load. Buckling load, in what happens in the buckling load, say this is a column, and I am applying a compressive load. What happens this time? It is buckling. This part is buckling. It may fail due to the excess compressive or due to the buckling. So the slenderness at that time is defined as the buckling. And one component may also get a failure due to the compression and buckling. It can experience both sides, a compression and a buckling. So three types of failure in the column and strut. Foremost is the compression, which is the prominent load onto the bar. Second one is your buckling load. Third one is your buckling and compression. Okay, coming to the next part. What is a buckling load? When a compressive load has to be applied, the minimum load at which the column tends to have the lateral displacement or a buckle. I am applying, this is a column, this one is a column, and I am applying a compressive load, it will tend to buckle. At that time, what happens? When it is buckling, so due to the compressive load, this load is defined as the buckle load. The displacement in the column, that is the lateral displacement is called as buckling. Safe load. Whenever your buckling load is divided by factor of safety, we get a safe load. We will also use this in the numericals, that how to calculate the buckling load, safe load. That will be simply, you will calculate the buckling load and you will divide with the factor of safety. What are the end conditions for this? Now, we are having 4 simple conditions, 4 equivalent length formulas, which we will apply to calculate the Elier's formula. What is that Elier formula? What is that 4 condition? Let us discuss that now. We are having a column, say this is a column. We will be applying 4 conditions on this. First most is the both ends are hinged on the pin joint. At that time, when a compressive load, because compressive load has to be applied upon the column or a strut. That is the foremost condition. Without it, it cannot be a column or a strut. So, from the top, we are experiencing a compressive load. At that time, both the ends are fixed. So, the equivalent length will be this part, which will be equal to the length of the column. Second condition. One end is fixed, other is free. When one end is fixed, it may start from here also. Here. So one end is fixed, one is free. At that time, equivalent length will be equal to the twice the length of the column. Second is, one end is fixed, other is pin jointed. Pin joint, you understand, when we just join through a pin, like a dozen pin we join. So equivalent length at that time when one end is fixed from the bottom, it may from the top, no issue in that. Just for your sake of understanding, I have drawn. One is fixed, other is pin joint. We get L is L by 2, L by under root of 2. Next condition is both ends are fixed. At that time, the length of the column will be equal to the half the length of the equivalent length will be equal to the half the length of the column. This equivalent length will be used in various formulas, from where your joint or your pin joint, your hinge joint, your fixed joint is from two points. These points are called as inflection points. Okay, just for your sake of understanding. Elier's formula. Elier's formula, in the Elier's formula, we are having a simple formula how to calculate the load on this part. So, we are having pi square EI over LE square. P is the critical load, which is due to the compression. E is the modulus of elasticity. I is the least movement of inertia of the column. LE is the equivalent length of the strut, which you have just calculated. 4 conditions will be given to you in this case. For example, a question will be given to you, which I will discuss after this part. So, we will discuss the question on based upon these 4 conditions over here. Just first complete the ranking hypothesis. Ranking hypothesis includes that how to calculate the ranking formula. In the ranking formula, basically we are calculating the load. For example, the Elier formula we were calculating the load, that is the Elier's load. In the ranking we are calculating the load due to the ranking formula. So its formula is 1 by P is P crippling by P Elier. We are putting the value of the crippling load as crippling stress into area. P Elier you have just calculated over here. Put the value in this part P Elier. On solvation of this, we put one more value. We know that I is equal to AK square. We will be using here in the formula also, which we are going to solve question. And we assume one constant, which is this, that is stress C by pi E square is equal to A. So we come with this derivation. We come up with this derivation. P is equal to stress C over this whole part is A now. So we come up with this relationship. P over A is over here. We calculate the value of PR, which is equal to stress C into A, 1 plus A by LE by K ka whole square. So let us solve one question, a simple question for the sake of understanding. Let us say we are having one column which is fixed at both ends or pin joint at both ends. Pin joint at both ends, LE is equal to L. Okay, first condition we got as LE is equal to L. Length is given, diameter of column is given, outer and the inner dia. Value of A is given to you, which you know what is A. E is given to you, Young's modulus. Yield stress, that is the crippling stress, is given to you. We need to find out the P here and PR ratio. Simple. P here is pi square EI over LE square. LE is your both ends are pin joint. LE is equal to L. So we put the value of pi we know 3.14. E we know is given to you 200 gigapascal. I is your pi by 64. D outer 4 minus D inner 4. LE is equal to L square. This whole you can easily calculate it from the given values. P Rankine. What is P Rankine? You have just derived the formula for this. Stress C into A over 1 plus A LE by K square. We know stress C is given to you 315 megapascal. Area you know 1 plus A you can is given to you directly. LE by K square. K you know that how to calculate the K value of the K, that is A into K square. So you can simply calculate the ratio. What is the answer coming from this numerical? 1.02. Okay. Similarly, in this part, we need to calculate the value for the equivalent length. If for the material the Young's modulus is 200 megapascal, we know area's load is divided by area into the Young's modulus. So its value is 200 into 10 to the power 6. It is given to you megapascal. Pi square EI is the formula for area's load. Area is I is equal to AK square. We have done over here also. I is pi by 64, D4 minus D4. This is given to you. K slenderness ratio, you can easily find out over here. So you have calculated all the values. LE is coming out to be how much? 1.2 meters, I guess. Mm. So this is all about the column and strut. In the last classes, we have done the derivations also for the end conditions. So this includes almost all the values for all the calculations for Elias load, Rankine load, end conditions, your buckling loads. So try to solve the rest of the questions. So if you require any help from me, you can come to me. So thank you class.